Good afternoon, all of you. And the last two sessions in the fourth module, today we'll be studying two important types of multiple access, FDMA and TDMA. We have two more other things like CDMA, code division multiple access, and orthogonal division multiple access, which we will be seeing in the next session. With that, we'll complete our fourth module and we'll enter into the fifth module. Okay. So let us see what is FDMA. In FDMA, what we are doing is that a band of frequencies is being allocated to each user. That means that each user is allocated a different frequency. A band means, you have two types. One is called as a full duplex and the other one is half duplex, right? So each user will be allocated two channels, or each user will be having a dedicated frequency channel or a frequency band. So we'll see, for example, we have code here and time here. See this graph, no? We have, say for the first user, we'll have it as a green color one. Here, we'll see that. Green, orange, another frequency, another one lighter green, another one frequency. Like this, every user is allocated a dedicated frequency for his transmission. Okay, like this we'll be having multiple frequency allocations. So one channel can be used by multiple users. This is called as FDMA, frequency division multiple access. So what we are doing in FDMA, we are allocating a frequency to each user, a unique frequency band or a channel. The channels will be often having a guard band. What is a guard band? Something that separates two frequencies, because multiple users are using, you may have a good chance of two signals getting interfered, right? So in order to protect this, what we'll be having guards. Okay, two guards, one in the beginning and the end, and so such a way. There are different types of how we'll be guarding the signal. All these things we'll see as we go on, but we'll not be able to see in depth. Although I wish I could have taken it in detail, unfortunately our syllabus also simply goes through these topics, and another one thing is that we are also running short of time. So the channels often have guard bands between them to compensate for imperfect filters, adjacent channel interference, spectral spreading due to Doppler effect, and so on. In FDMA, the only and one most important formula that you have to study is the number of channels that can simultaneously support a FDMA system, that is given by N. N is equal to Bt minus 2 B guard by Bc. Okay, Bt is the total spectrum allocation, whatever you have in total. B guard is the guard bandwidth or the frequency guard that is being allotted to, and C is the entire channel bandwidth. There are possibilities that you may get problems based on the number of channels that can be allocated in a FDMA system. Quite easy. BT stands for the whole or the total spectrum. B guard is the guard allocated, so that I told you now we need a protection from interference. That is called as B guard, and BC stands for the entire channel bandwidth. So these are certain features of FDMA. Usually you will be getting questions based on these things. because you need to write the points. Here I can do nothing more than dictate all the points. You need to note this down and you need to study this for your exams. Okay, FDMA channel carries only one phone circuit at a time. I've used some color codes to make you understand some of these things, these features are positive and some of these things are not that good. So the things that are not so good are given in red, and things that are okay or things that are something like advantages are given in green. Okay, the FDMA channel carries only one phone circuit at a time. If an FDMA channel is not in use, then it sits idle and cannot be used by other users to increase or share the capacity. It is essentially a wasted resource. So we are wasting a fund frequency band because each user is allocated a dedicated frequency, right? So that if the user is not using, that is kept idle. That's a wastage of resource. After the assignment of a voice channel, the base station and the mobile can transmit simultaneously and continuously. Once we establish the connection, then it can happen continuously. The bandwidth of FDMA channels are relatively narrow. Okay, we are using narrow band as each channel supports only one circuit per carrier. That is, FDMA is usually implemented in narrow band systems. This is an important point because we will be comparing this with TDMA. In TDMA, we will be using a wider band of frequencies. Time is inverse of frequency, right? If you could keep this point in mind, you could easily explain the differences or you could compare between FDMA and TDMA. So here we are using a narrow band, the bandwidth is usually narrow. The symbol time of a narrow band signal is large as compared to the average delay spread. This implies that the amount of inter-symbol interference would naturally be low, right? Thus, little or no equalization is required in FDMA narrow band systems. So to make the point clearer, there is no option for inter-symbol interference. Actually, if at all it happens also, it happens to a very little extent because first thing is that we are using a narrow band signal and the option that the delay spread cannot be larger. What happens when delay spread is larger? Only in that case we will be having the possibility of inter-symbol interference, right? Only when one signal, the previous signal interferes with the next signal, we have inter-symbol interference. Here the band is narrow, so the delay spread is less, so there is little chances for inter-symbol interference. The complexity of FDMA mobile systems is lower when compared to TDMA systems, though this is changing in digital signal processing methods, changing in digital signals, and we have in TDMA what happens is that when you start using digital signaling, what happens is that the complexity is getting slightly reduced or is coming into a different phase. We will see about it as we go on. Shall we proceed to the next point? Since FDMA is a continuous transmission scheme, fewer bits are needed for overhead purposes such as synchronization, framing, etc. as compared to TDMA. So when we look into the frame structure of TDMA, it has more additional guard bits or something that overhead bits, things that are required to identify the systems, or so many other things that is all the things that are not the original message. That is called as this overhead purposes. Okay, the headers and other kinds of things. So this is occupying some resources in TDMA, and it's an advantage for FDMA. You have a fewer bits that occupy this overhead systems. FDMA systems have higher cell site system costs as compared to TDMA system because of single channel per carrier design and the need to use costly band gap filters to eliminate spurious radiation at the base station. Okay. So in FDMA, as we have already discussed, we are dividing the system into frequency bands and each user is allocated a particular frequency band. Okay. So what happens is that they have in the cell site you have a system cost that is comparatively high with respect to TDMA. The FDMA mobile unit uses duplexers since both the transmitter and receiver operate at the same time. This results in an increase in the cost of FDMA subscriber units and base stations. FDMA requires tight RF filtering to minimize adjacent channel interference. We have seen that we are using multiple frequencies over the same channel. What happens is that there is a possibility of one set of frequency bands getting interfered with the next set. So adjacent channel interference is a major problem that we might face while using FDMA systems. So coming to the next topic in our syllabus, time division multiple access or TDMA. Time division multiple access systems divide the radio spectrum into time slots, and in each slot only one user is allowed to either transmit or receive. TDMA channels occupy the entire system bandwidth, which is typically wideband, compared to FDMA, which was a narrowband system. In time band, we are using the entire frequency spectrum. We are using the entire bandwidth, and each user is allocated not a frequency but a time slot, so that every user channel is allocated one particular time slot. This time slot is equally divided among the total number of users. So what happens is that we have a larger bandwidth. More information can be transmitted per user but for a shorter period of time. Okay. And the cyclically repeating time slots imply that transmission is not continuous for any user. That means no user will be given the continuous communication. Although in practice, when you do it in real time, the user may not be able to find it out. But what happens is that there will be n number of users, and each user will be provided with a particular time slot for transmission. So this is a graphical representation where we have multiple channels. Say there is a time slot is divided for each channel. Channel 1, channel 2, channel 3, channel K, and then again channel 1 is repeated, channel 2 is repeated, and so on. So we have it as time division multiple access. In the next slide, I'll explain this more, but this is only for you to draw in your exams. The next slide, you can see a more colorful image coming up. This is going to give you more details about TDMA. but you cannot make it colorful in your exams. So you can just draw this diagram for your exam sake so that the entire time slot is divided for each user. The same graph or the same system, you can see that, let us imagine that user 1 is allocated a time slot. Let the user 1 be given one particular color. I've given it here as blue, user 2 for red, user 3 green, and then you have multiple number of users coming up, and again after a particular time period user 1 is again allocated his time slot, user 2 like this, without, in reality this time is divided in microseconds or much less than that, even in nanoseconds, so that the user is not aware of the time gap. We have compensated for the time gap in the user. The next important thing what we need to understand is the efficiency of TDMA. The efficiency of TDMA is a measure of the percentage of transmitted data that contains information as opposed to providing overhead for the access key. We did not have this in our TDMA. So the number of overhead bits per frame, the number of overhead bits per frame BOH is equal to NRBR plus NTBP plus NTBG plus NRBG, where NR is the number of reference bursts per frame, NT is the number of traffic bursts per frame, BR is the number of overhead bits per reference burst. So here we are comparing the overhead bits with the message. That is what is the efficiency of TDMA. That is number of other bits that we are using. BP, the number of overhead bits, the preamble in each, per preamble in each slot. Okay. The number of equivalent bits in guard time interval is given as BG. BT is equal to TF into R, where TF is the time frame duration and R is the channel bit rate. I'll try to make out some problems and try to solve it and give it to you as much as possible, but I'm not very sure how far we can do that because of lack of time. So efficiency, the frame efficiency, neta F is thus given as neta F is equal to 1 minus BOH by BT into 100 for percentage calculation. We calculate the efficiency in terms of percentage. So roughly speaking, efficiency of a TDMA system depends upon the space or the time that is being consumed by the overhead bits, which does not include the main part of the message. Okay. So as we have seen in FDMA, we will be seeing number of channels in TDMA systems also. The number of TDMA slots that can be provided in a TDMA system is found by multiplying the number of TDMA slots per channel and is given by N is equal to M into B dot minus 2 B dot by BC, where M is the maximum number of TDMA users supported on each radio channel. Rest of all the terms are already defined, right? Next, we'll write down the important points or the features of TDMA. TDMA shares a single carrier frequency with several users where each user makes use of non-overlapping time slots. The number of time slots per frame depends on several factors such as modulation technique, available bandwidth, etc. Data transmission for users of TDMA system is not a continuous one but occurs in bursts. This results in low battery consumption since the subscriber transmitter can be turned off when not in use. So next point in TDMA, because of discontinuous transmission in TDMA, the handoff process is much simpler for a subscriber unit since it is able to listen for other base stations during the idle time slots. An enhanced link control such as that provided by mobile assisted handoff, what we call it as MAHO, can be carried out by a subscriber by listening on an idle slot in TDMA frame. TDMA uses different time slots for transmission and reception. So you have two chances. In a full duplex system, you have different time slots, one for transmission and one for reception. Thus, duplexers are not required. Even if FDD used, frequency division duplexing is used. A switch rather than a duplexer inside the subscriber unit is all that is required to switch between a transmitter and a receiver using TDMA. Next point, adaptive equalization is usually necessary in TDMA systems since the transmission rates are generally very high as compared to FDMA. So we need to have adaptive equalization. We have studied what is adaptive equalization, right? Equalization that depends upon the channel conditions you need to keep equalized. The system should be adaptable to the conditions outside. So we need an adaptive equalization for a TDMA system since the transmission rates are usually very high when compared to FDMA. In TDMA, the guard time should be minimized. If the transmitted signal at the edges of a time slot are supported sharply in order to shorten the guard time, the transmitted spectrum will expand and cause interference to the adjacent channels. In high synchronization, overhead is required in TDMA because of the burst transmissions. TDMA transmissions are slotted and this requires the receivers to be synchronized for each data bus. In addition, guard slots are necessary to separate users and this results in TDMA systems having large overheads as compared to FDMA. TDMA has an advantage in that it is possible to allocate different numbers of time slot frames to different users. Thus, the bandwidth can be supplied on demand to the different users by concatenating or reassigning time slots based on priority. So with this, we have seen all the important points with respect to FDMA and TDMA. Basically, I believe that you have understood what we are doing with TDMA and CDMA. In frequency division multiple access, we are allocating a dedicated frequency for each user. In time division multiple access, what we are doing is that we are allocating a dedicated time slot for each user, but no user will get continuous transmission or no user will get a channel that is continuous. Our objective is to support multiple users at one particular point of one particular time band. like frequency band, you can imagine time band. The coming days or the next session will be dealing with code division multiple access CDMA and OFDMA, which is remaining in our fourth module. So thank you very much. Thank you very much for listening to me. So we'll meet in the next class with CDMA and OFDMA.